Grade sevens, there's probability experiment in your getting started activity that a lot of people have been asking me about. So I thought I would kind of look at it in a little more deeper fashion in case you haven't really seen it before. It's a pretty easy experiment. It's pulling marbles from a bag. You've probably done it when you were a lot younger, but you might not be thinking about it now. So let's stop and take a look at it and take a look at it from a grade 7 perspective. So I thought I'd replicate the experiment from your textbook. And in the experiment in your textbook, there are 3 marbles in a bag, a green, a red, and a blue. And so what you're going to do is you're going to pull one marble out of the bag without looking, and it asks, what are the possible outcomes? And the outcome, of course, is the result of a probability experiment. And that's what you're doing here, even though it's very simple. So the outcomes are you could pull the green, you could pull the red, or you could pull the blue. How many choices does that give me? It gives me 1, 2, 3 possible outcomes. Okay. Now I could ask you a specific question, and I could say, for example, what are the odds of getting the green marble? The green marble is right here. It represents 1 out of the 3 possible outcomes. So to get the green marble, you will have a 1 out of 3 or a 1/3 chance. And that's where we can use the fractions to model the probability. That also means, of course, that the blue has a 1 out of 3 chance and the red has a 1 out of 3 chance. And that's, that works because when you add up all the probabilities, you get 1, right? So you have to add them all up and they all have to equal 1 in the end. Okay? So I think where people were kind of finding it tricky is when we pull multiple marbles out of the bag. You have multiple turns. So let's look at the top area here. Let's focus ourselves right up here. And let's pretend we pulled the green marble first, okay? And then we put it back into the bag and we pull another marble. Here are my possible outcomes. I can get the green and then I can get the red with my second choice. I can get the green and I can pull the green out again with my second choice, or I can get the green and I can pull it out with the blue. Okay, so I've got those possible outcomes, a green and red, a green and green, and a green and blue. I can also pull out the red marble first and then pull the red marble second, pull the red marble and then the green, and pull the red marble and then the blue. And I can start off by pulling the blue marble with a red, with a green, and again with a blue. Okay, so what that means is that each of these represent possible outcomes that could happen. So just to make sure we're clear, what I'm saying is I could pull the green marble first, put it back in the bag, and then pull any of the 3 colors to go with it. I could also pull the red marble first, put it back in the bag, and pull any of the 3 colors as my second choice. Or I could pull the blue marble with my first pick and then pull any of the other colors. So that means I have a number of multiple outcomes. I've got 3 up here, 1, 2, 3, green, red, green, 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 blue. I've got 3 here, red, 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 green, and red, blue. And I've got 3 here, blue, red, blue, green, blue, blue. So that means I have a total of 9 possible outcomes. Now, what you would have to ask me is you'd say, Mr. McPherson, what are your chances, for example, of getting 2 green marbles? So I'd look at all my possible scenarios here. Are there any options when I pull blue first? Nope, can't get 2 there. Can't get 2 when I have a red. When I pull green, I can get green and green 1 time out of 9. So the chances of that are 1 time out of 9. Okay. If I wanted to say what are the chances of pulling a blue marble at all? Well, I've got the following chances. I've got 3 chances here because I've pulled the blue one first. So blue, red, blue, green, blue, blue. I also have a chance of getting a red and a blue. So that's 4 chances. And I have a chance of getting the green and the blue. So that would be 5 out of 9 chances. So now I've done the experiment 3 times where I've pulled a marble, put it back, pulled another marble, put it back, and pulled a 3rd marble and put it back. And so this is what my options are. Now I'm going to actually show you because it's kind of really big. And as you can see, I've even had to stagger it just to fit everything. So I can go green, 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 blue, green, red. Okay, so these are my first choices here. But then I have 3 additional choices that branch out of each of those. So 3 additional probabilities. I'll just sort of highlight them here. Okay, so those are the different choices. So to sort of look at the odds of any particular outcome, it depends on whether you want them in order or not. So if I want them in order, Now, first I have to keep in mind there are 9 possible outcomes here, 9 possible outcomes here, and 9 possible outcomes here. So for this whole experiment, a chance of 27, okay, of pulling any one particular combination. Now, if you said, Mr. McPherson, can you show me what are the odds of pulling first a green, then a blue, then a blue? So I would look at it, I have to do green first, then blue, then blue. That only happens one time in that particular order, okay? Green to blue and blue to blue, okay? So that would be a 1 out of 27 chance. If you wanted to say, what are the odds of getting a green and 2 blues together in any combination? Well, that's a little different. It's not much different. There's one chance. I could also go blue to green, 1 green and 2 blues, or I could go blue to green to blue. Okay, 1 green and 2 blues. So it does give me a few more possibilities here to get that. So that would, I guess, would have been 3 out of 27 if the order doesn't matter. Okay. So you might be wondering how, aside from drawing all these marbles, do I explain what the outcomes are, explain what the possible choices are. So here's how you can do it. I've just zoomed in on one section, the section where we pulled a red first of the 3 pull probability experiment. So every probability, first of all, is going to start with red, okay? And then here's how I would look at it. So I can do, for example, red to green to green, red to green to blue, and red to green to red. So let's look at how we would mark that. We would say, okay, my probabilities are red, green, green, red, green, blue, and red, green, red. And then I would move down here and I would have red, blue, green, red, blue, blue, and red, blue, red. And finally, last thing, red, red, green, red, red, blue, and red, red, red. Now, the reason you would do this is it makes it a little easier to sort of look at your choices without having to draw it all out and see the different combinations. So, for example, if I said, okay, just doing this experiment, what are your odds of getting all 3 reds? And I could find it easily, red, 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 right there. Or if I said, what are your odds of getting a green? I can find anyone that has a green. 1, 2, 3 have greens, 4 have greens, and 5 have greens. So looking at my combinations here, I could say, for example, that I have a 1 out of 9 chance of getting all reds. I could say I have a 1, 2, 3, 4, 5 out of 9 chance, though, of getting at least 1 green. Okay, so that's sort of how we look at this. That's the experiment. Obviously, if you did 4 pulls out of the bag, then you would expect exponentially grow every single time. And hopefully you recognize that as the number of pulls gets larger, the odds of getting any one combo are less. If there were just 3 marbles and you said try to pick a red, you'd have a 1 out of 3 chance, which is pretty good odds. If you said try to pick 3 reds in a row, suddenly you're down to a 1 out of 9, and actually that would end up being 1 out of 27 chance for the entire experiment. So you're down to very, very, very poor odds. Sort of shows you sort of the dangers of gambling. All right. So anyway, use this as you move forward. We'll probably be using this sort of experiment more. Hopefully this rings a bell to things you've done in the past.